Hi everyone, I'm Annie. I'm a rising fifth year working with Andrew Jacobson, and I'm going to talk to you about chemical weathering in the Icelandic Highlands. The Highlands are the central plateau, as shown in this picture, where it's basically nothing but rock, ice, and rivers. So chemical weathering is where atmospheric CO2 chemically reacts with and dissolves silicate minerals, and this process sequesters carbon and controls climate over time. And I study this by looking at calcium in rivers using calcium isotopes. So all the calcium in Iceland originates from basalt, and the initial pool of calcium has pretty narrow calcium isotope composition. So basically anything that plots below this line has been affected by fractionation where light isotopes were preferentially removed. And anything that plots above this line is a fractionated reservoir. So the first result I want to share with you is that hyaloclastites, which are a glassy volcanic breccia, as shown in these pictures, formed during subglacial eruptions, have similar calcium isotope compositions to bulk basalt. So if all of this calcium was just directly dissolving into rivers and sequestering carbon, we would expect that rivers would plot somewhere along this red line, but they actually don't. They plot really high above the red line. And I'm interested to know why this is. Another result I want to talk about is that altered hyaloclastites shown in these pictures are isotopically light. So these green data points plot below the red line, which says that fractionation during alteration is causing these rocks to kind of retain the light isotope, and then the water around them would be enriched in the heavy isotope. So my current hypothesis to explain what's going on here is that alteration of these hyaloclastites is causing fractionation in this direction, with light isotopes being enriched in the altered rocks. And this is therefore causing a residual pool of fractionated calcium to be heavy in groundwaters, from which these calcites in yellow precipitate, which is why the calcites plot above the red line. And also, I think that calcites are controlling river chemistry. So calcite dissolution is causing the rivers to be so far away from the initial basaltic value. So I hope to further investigate this the rest of this year. Basically, the implication of this is that a lot of the calcium in these rivers comes from calcite and not basalt. So this means that CO2 drawdown is probably less than we previously thought. Thank you.